his 7th grade math class.
The students at Graham Middle School in Mountain View, California took the challenge. Let's see some of their results. Recall the 2 questions in this activity. 1. What are the dimensions of a rectangular prism that has a volume of 24 cubic inches, fits into an 8-inch PSA, and has the maximum surface area? And 2. If the volume stays the same, does a tall cylinder or a wide cylinder have more surface area?
We're going to get the biggest surface area by using points. 2 inches. What do you guys think? Is that going to fit? Remember, our goal is thinking about how to maximize surface area. The surface area was 77.6. What are we going to say? What dimensions are we going to recommend?
6 by 5 by 0.8.
So guys, what did you find?
When you flatten a rectangular prism, the surface area increases.
You can get different answers depending on how high you make the rectangular prism.
When the radius increases, the surface area of the cylinder increases.
Okay, let's summarize. The surface area of a rectangular prism is the sum of the surface area of its 6 sides. The volume of a rectangular prism is the length times the width times the height. A rectangular prism has the minimum surface area when it's a cube, and the surface area increases as you flatten it. The surface area of a cylinder is the sum of the areas of the circles at the top and bottom, and the area of the side. The volume of a cylinder is the area of the circle at the bottom times the height of the cylinder. When the volume is the same, a tall cylinder has less surface area than a wide cylinder.
We have to do calculations like this when we lay out the design of all the components of the PSA.
Okay, so Dan, what is the future of the PSA?
Well, once we're able to make the PSA smaller, we'd like to consider a PSA which could further interact with the spacecraft. Imagine a PSA with arms that could actually push buttons, retrieve tools, and better interact with the ISS.
Well, developing effective artificial intelligence is a big challenge, and being able to understand what the astronauts say is especially difficult because our brains understand things in context or the situation we're in.
Well, a critical part of the future of the PSA is the vision system. We need vision for everything from navigation and control to identifying hazards to doing inventory tracking, and also to recognize the crew, because we need to customize schedules and training procedures to go with a particular crew member. And we also use it as sort of remote eyes for the ground folks that are running the operation, so they can inspect the station through the eyes of the PSA. And being able to interpret what you can see will save us a great deal of time.
My thanks to Yuri, Keith, and Dan for all their information on the PSA. And don't forget, keep checking the PSA website for the latest developments on this personal satellite assistant.